Thanks, Zoe, for this warm intro. Hello, everybody. Welcome from my side as well. Hope you all are doing great. I know it's late, but this will be interesting. Today, I want to talk to you about data ownership and how we're going to achieve that with decentralized storage in Web3. And for today's talk, I basically want to answer three fundamental questions. The first one would be, what is decentralized storage? Then why do we need it? Why is it so important? And then third, how does Crust make it happen? And to jump right into it, I want to present you this quite impressive graphic. This shows the total amount of data created, consumed, and stored on a global basis. And currently in 2023, we store around 330 million terabytes of data on a daily basis. And this trend is increasing rapidly. And this also means that we have an increasing demand for resources, or storage resources. And not just that we collect more and more data on a daily basis, we also become more and more dependent upon this data. So what personally concerns me a little bit about this trend is that when looking at the current cloud market, around 65% is in the hands of only 3 big players. And this obviously means a huge concentration of power and data. And that's something we try to avoid so desperately in Web3. But also looking at the evolutional timeline of data storage systems, we can draw a lot of similarities between the transformation of the ownership principle from Web 1 to Web 3. So in fact, in the beginning of the digital data storage era, we were used to store our data on our own infrastructure, our own hard drives, which we owned totally with our own control. The only issue was maybe that sometimes it was hard to access this data or to share this data with our peers, friends, colleagues, or whoever. With Web 2, we were introduced to centralized cloud services, and suddenly we gained a lot of convenience. We were able to access our data from anywhere, at any time, and also were able to scale our storage capacities with just a click of a few buttons. The only downside to this was that suddenly we weren't in the possession of our own data anymore. We had to put our full trust in this third party who was gatekeeping our data. In Web 3 and with decentralized storage, we actually have the chance to combine the beauties out of both worlds, which means we can maintain the ownership as if we own the hardware ourselves, while maintaining the accessibility and convenience we were used to from Web 2. And the best of it, we don't have to put trust in anyone, because it's all guaranteed by a trustless protocol. But the ownership issue and the trust issue is by far not the only downside to centralized services. Those centralized services usually run on a single point of failure architecture, which is highly exposed to any kind of outages, security breaches, or other showstopper events. Furthermore, data on centralized services can be muted. It can be censored. We have seen it multiple times, and there's no guarantee that the storage provider is okay with what you're hosting. With decentralized storage, on the other hand, there is no single entity in control over your data. And data is spread across a network of distributed nodes, which are backed by blockchain technology. This keeps the data guaranteed, available, tamper-proof, and also 100% immutable. So since we know now what decentralized storage is and how it differs from centralized services, I want to talk about Crust Network. So Crust Network is a layer 1 blockchain and protocol for decentralized storage and hosting services. And we're actually based on top of IPFS. So for those of you who don't know what IPFS is, I want to take a quick loop because it's super important to what we're doing. IPFS stands for Interplanetary File System, and it's a peer-to-peer based distributed file storage system. It's by far the most adopted file storage protocol in Web 3. It's adopted by the largest players like OpenSea, Uniswap, many more. But it has some downsides. And the biggest downside probably is that the storage on IPFS is not incentivized. This means node operators who contribute their resources to this shared network don't get any rewards for providing the resources. On the other hand, users don't get any service guarantees for the availability of their data. So in other words, you can upload your data to the IPFS network, but you won't be knowing for how long the data will be available or how many replications you receive of your data. And that's exactly where Crust Network comes into play. because Crust provides this incentive and service layer on top of IPFS, which enables node operators to receive rewards in form of blockchain emissions, but also storage fees from the protocol. But also it goes beyond and matches those storage resources with users who have demand for these resources. And all of those orders are executed totally on chain on our layer 1 blockchain, where it's recorded and totally transparent. Over the last couple of years, Crust was able to build an impressive tech stack from our infrastructure layer over our protocol layer, the interoperability layer, but also the application layer. But I would say the most important of this is our decentralized physical infrastructure, consisting out of our validators, our gateway providers, and obviously our storage providers. And I want to have a quick look at this infrastructure and want to give you some metrics about our protocol and what we're offering. So currently we have over 1,600 individual nodes contributing their resources to our network. And overall this makes up to like 700 petabytes or 700,000 terabytes of total storage capacity. And we launched our mainnet in September 2021. And since then, we already processed more than 1.8 million file orders and uploads. And we don't just stop there. For every file upload, we have on average 33 replicas that are distributed over our network. But what is all this infrastructure without services which we can build and leverage on top of this? So to put it in 3 categories, we offer Crust IPFS gateway services, which basically lets you upload your data to the IPFS network and to our infrastructure in the most seamless way. We use super fast Thunderbolt gateways for that, and the best of it is we don't charge for any additional file retrievals, and we don't put any limitations on your file retrievals. The next service, probably our most popular one, is the Crust IPFS pinning service. This makes sure that when your data is on IPFS, that it stays on IPFS, that it will be maintained according to your needs, which will be fixed in a smart contract. And we use this multi-replica approach for file storage to also ensure decentralization on the most basic physical level. And I think that's a super important part because this also increases performance, decreases latency, and has many more advantages. And the last service probably would be our Crust file query services, which provides you with additional information about your file orders or the status of your file via different Explorer tools, for example. But now have a look at all those beautiful things you can build on Crust Network. Crust Network, compared to other decentralized storage protocols, not just offers suitable solutions for cold storage, but also for hot storage. And I want to present a few of them. So a very popular use case is decentralized hosting of your dApp or your website. So I brought some snippets with me where we can see some past events where Web3 services run into outages, run into security issues, and that's something that could have been avoided with decentralized hosting. With decentralized hosting, you basically increase your uptime and you decrease the risk for any front-end related security breaches like DNS hijack attacks, DDoS attacks, and whatnot. And this best practice of hosting your website is actually realized by Uniswap, Avi, Polkadot apps, and many more who host their front-end via Crust Network. And we are really proud that we do that. And I also want to take this opportunity to raise some awareness for a campaign we recently launched with our good friends from Apelon. And this campaign is called Web3 Approved. And with Web3 Approved, we want to encourage developers, builders, and Web3 projects to finally practice what we preach and to host their web page totally decentralized. And we don't just encourage them, in fact, we incentivize them. And we do that by providing 100 years of free storage or free website hosting for the very first 100 projects onboarding this initiative. So if you are keen to check it out, feel free to hit me up after this talk. Feel free to scan up this QR code. But I will be around. Another very important use case is storage of NFT metadata. Most of you probably know that not all metadata of NFTs is stored directly on chain, at least not in most cases. The reason for that is simple. Storage on-chain is quite expensive. I think 1 megabyte storage on Ethereum is around $200,000. Obviously, there are other chains that do it for cheaper, but in general, it's stored off-chain. So the NFT contract actually points to an off-chain location where the data is stored. This doesn't mean that we have to rely on centralized services. Crust can store your data totally decentralized in an off-chain environment which is permanent and immutable. And yeah, we also work with some quite big projects to realize this use case. And the last use case I want to mention here is general file storage. I probably could sum up a lot of different projects in this bracket, but I want to just mention a few of them. For example, we have this really cool use case with robonomics, where we store machine data collected by those cute robots from Boston Dynamics directly to Crust Network. We also work with Polkadot, where we are in the process of opening an XCMP channel to provide backup services for their decentralized order book. And here and there, Crust also builds some applications themselves. For example, Crust Files is like a decentralized version of Dropbox with a very easy-to-use interface. And for everybody who wants to experience decentralized storage for the very first time, this is the way to go. Just log in with your MetaMask and start uploading your files with drag and drop. Super easy. But the interoperability of all those services obviously is super important because we want to make sure that all builders, all developers from as many ecosystems as possible have access to those decentralized storage resources. And how do we do that? Obviously, within the Polkadot ecosystem, the most obvious way is to connect with us via our X storage palette or via XCMP. So we have our Crust parachain on Polkadot since the beginning of this year, and we already extended our lease for the Kusama parachain. And we welcome every parachain to make use out of this decentralized storage to finally achieve full-scale decentralization. But we might be a substrate-based chain, but definitely not limited to the Polkadot ecosystem. In fact, we provide our storage services to many other contract-based ecosystems, and we do that via native cross-chain smart contracts, which we deploy to their site, to their ecosystem. This means that also developers from many other ecosystems can leverage our services and can pay in their native token. And another cool fact is that Crust is actually mentioned in the official documentation of Ethereum, of Polygon, of Near, and many more as recommended storage solution. And last but not least, there is a way to connect to Crust in a totally IPFS native way. This is totally chain agnostic. It doesn't matter where you're coming from. You directly interact with our decentralized storage market, can upload your data to IPFS, or if your data already is on IPFS, you can just additionally pin it with our service. And before I wrap it up, I still want to give you some hands-on information about our very new product we recently launched. This product is called Crust Cloud, and it's basically our commercial product line on top of our infrastructure and on top of our protocol. And Crust Cloud is something big for us because we're going to redefine the way how we think about decentralized storage in Web3. And we do that by introducing the concept of Web3 storage buckets. Web3 storage buckets is basically an NFT-gated storage capacity which lives on Crust Network and on IPFS. In other words, your NFT points to a storage capacity which is on IPFS, yeah. And I want to tell you a little bit more about what promises those buckets hold for the user. So first of all, it's fully decentralized on Crust Network, obviously. Then it's truly immutable. Every bucket comes with an IP and S name, can be integrated with naming services, with digital identity services, and much more. And it's totally NFT gated. So no KYC, no login with username, password, etc. You hold the NFT in your non-custodial wallet, and you just can log in. And the best of it, all of those buckets come in various sizes and types. So with the launch of Crust Cloud, we launched our permanent bucket, which basically guarantees you permanent storage on IPFS with a one-time upfront payment. But we're also going to release our renewable bucket, which works more like a subscription-based model, and the user can extend it on demand. And all buckets are totally scalable in size, and you can mint a 1 gigabyte bucket or a 1 terabyte bucket. And I want to quickly show to you how it works. So you go to our UI, crustcloud.io, and you can mint your desired storage bucket. The bucket will be created, all metadata will be created around it. You will receive it to your wallet. And afterwards, you can use it. You can access it via our web UI. You can access this via RESTful APIs. And your NFT basically serves as authentication token. And because it's basically not different to any other NFT, you can transfer it between different accounts, and you even could trade it on OpenSea. or any other NFT marketplaces. And that's a screenshot of our user interface where you can select your different bucket. And currently we are priced at $1 per gigabyte for permanent storage, which is below 20% of what Ari, for example, currently asks for. But the best of all of this is, and what gets me really excited about this, is that with this new concept, for the very first time, we will be able to own our storage capacities in the same way we own all of our other on-chain assets. Think about your normal tokens, your NFTs, your liquidity positions, even your liquid staking positions. All of them you can hold in your non-custodial wallet. For all of them, you have full proof of ownership on-chain. All of them you can transfer between different accounts. And all of them you can trade on marketplaces and exchanges. Why can't we do that for our data yet? Or other question is, do we really own our data if we can't do that? And I'm super excited to see all those new use cases we're realizing based on top of this technology. And I'm welcoming everybody who is interested in this and wants to talk about how you can realize your decentralized storage application based on Crust Network. And that's from my side. Thank you guys for the attention. And I want to leave you with this meme. I think that says everything. Thank you.